Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from negative infinity to 0, z times e to the 2z dz. This is an improper integral. As we can see, we have an infinity in one of the limits of integration. So we use the definition. The limit as a gets closer to negative infinity, the integral from a to 0, z e to the 2z dz. We need to find an antiderivative of that z e to the 2z. So let's go over on the side, see if we can't do that. We use the integration by parts, so we can let u be equal to z, dv equal to e to the 2z dz. du would then just be dz. V would be an antiderivative of e to the 2z dz. So v would be equal to 1/2 e to the 2z. And now we're ready to set up the integration by parts. So that integral would be u times v. So 1/2 times z e to the 2z minus the integral of v, which is 1/2 e to the 2z, du, which is the same as dz. One half z e to the 2z. When integrating the 1/2 e to the 2z, we get another 1/2, so this actually becomes negative 1/4 e to the 2z. Plus c. So that's an antiderivative. So over here we end up with the limit as a goes to negative infinity. 1/2 z e to the 2z minus 1/4 e to the 2z evaluated, because we're on a definite integral, we no longer need the plus c, but we evaluate from a to 0. So let's do those evaluations. The limit as a approaches negative infinity, 1/2 times 0 e to the 2 times 0 minus 1/4 e to the 2 times 0 minus, then we substitute in a, so 1/2 a times e to the 2 to a, 2 times a minus 1/4 e to the 2 times a. All right, so then we're trying to take the limit. Of course, this first term, everything in the world is a constant. So whatever we get there, the limit of it is just going to be that value. So let's see. 1/2 times 0 e to the 2 times 0, that is just going to be 0, so it goes away. Over here, 2 to the 0 is 0, e to the 0 is 1. 1 times negative 1/4 is negative 1/4, so we have negative 1/4. Minus, now we get over here to this integral in this space. Well, notice that a is getting closer to negative infinity. So, in fact, if we consider, we have exponents. We have 2a and 2a as exponents. If a is a negative number, then that's going to drop that factor into the denominator. So really, we could go over on the side, and we could say that the limit of 1/2 a e to the 2a minus 1/4 e to the 2a as a goes to negative infinity is equal to the limit as b goes to positive infinity of 1/2 negative a divided by negative b divided by e to the 2b minus 1 over 4 e to the 2b. So all that we've done here is we say that a is the same as negative b, and we just substitute that in basically. Okay, now we notice that as b gets closer to infinity, then naturally this factor is going to get closer to negative infinity. This factor is going to get closer to positive infinity. So we have an indeterminate form. Over on this other term, so we'll come back to that indeterminate form momentarily. On this other term, b is getting closer to infinity, which means this whole denominator is getting closer to infinity. And if you take 1 divided by something that's getting closer to infinity, the whole thing gets closer to 0. So that term just simply goes away. So now we need to deal with this other term where we have an indeterminate form. Well, for an indeterminate form, you could apply L'Hopital's rule. So by L'Hopital's rule, we get that indeterminate form limit is equal to the limit as b goes to infinity of the derivative of the numerator, which becomes negative 1/2, divided by the derivative of the denominator, which is 2e to the 2b. You have to use the chain rule there. Now, this limit, the numerator is getting closer to negative 1/2, but the denominator is getting closer to infinity. See, b is getting closer to infinity, which means 2 times b is getting closer to infinity. E to the b is closer to infinity, so 2 times that's closer to infinity. Negative 1/2 divided by something that's getting closer to infinity is getting closer to 0. So this whole thing actually just goes away in the limit. So finally, our limit ends up being negative 1/4. This tells us that the original integral, namely the integral from negative infinity to 0, z e to the 2z dz, converges, and furthermore, it's equal to negative 1/4. So let's write that conclusion. So the integral from negative infinity to 0 of, let's check it again, z e to the 2z dz converges and is equal to 0.